These are the newest images of 3I Atlas from yesterday. And I'm pretty sure this is actually the most shocking anomaly we've seen about this object, because the only possible explanation until now was that it's breaking apart. So in this video, I'll break down everything we know about what's actually happening with 3I Atlas. Let's first talk about why everyone was convinced that it should be fragmenting or breaking apart. And then we'll talk about what the newest images actually reveal. So on November 9th, we captured these images showing a tail and a sunward tail extending millions of kilometers. But for comets, gas flows out at only about 1,500 kilometers per hour. That's pretty slow for space. So for the tails to stretch out millions of kilometers at that speed, the comet would need to be shooting out gas constantly for a couple of months. But images from just a few days earlier showed absolutely no tail at all, which is just one of the weird parts about the tails. The comet would need about 1,600 square kilometers of surface area absorbing sunlight. That's the same as a sphere 23 kilometers across, but Hubble measured 3I Atlas at only 5.6 kilometers across. The math showed us it needed to be 4 times bigger than what it actually was. So we calculated how much material these tails must be carrying away from 3I Atlas. And the numbers are pretty shocking. Estimations showed us 3I Atlas has to be losing about 50 billion tons of material per month, which is pretty disturbing considering the object is supposed to weigh only about 33 billion tons. But we have actually seen this before. The comet Shoemaker-Levy 9 broke apart in 1992, and the total amount of material it released was way more than what we thought the original comet weighed. But that made perfect sense once we realized it had broken into 21 different pieces. These pieces then have more surface area for the sun's heat to cause more ice to turn into gas, creating more visible jets and tails. So the only logical explanation for the 7 jets seen on November 8th and the massive multi-million kilometer tails in the November 9th images was that 3I Atlas had fragmented into different pieces, because there is no way a solid object can lose more mass than it weighs. So let's talk about what the new images actually reveal. On November 11th, 2 astronomers named David Jewett and Jane Liu pointed a telescope in the Canary Islands at 3I Atlas. When they published their findings, they gave it a very simple title: 3I Atlas Still Single. So not broken into pieces, not fragmenting, not scattering debris everywhere. But here is what makes these images so important. They did not just look and say, "Yep, it is still together." They actually measured and analyzed everything in detail. The images show 3I Atlas is about 1.5 astronomical units from the Sun. That's about 214 million kilometers. And it's a little over 2 astronomical units from Earth, which is about 320 million kilometers away. They observed a region around the comet that was about 500,000 kilometers wide, so they were looking at a huge area to find any signs of breakup. What they found was one single bright nucleus. That is the solid center of the comet. Around it is an active glowing cloud of gas and dust called the coma. The coma has a complex shape with different structures in it. They saw 2 tails pointing in opposite directions, just like we saw in the previous images. One tail is pointing almost directly toward the sun. They measured its angle at about 106 degrees. The sun was at about 115 degrees. So this tail is pointing at the sun with only about a 9-degree difference. This is called an anti-tail, and it's pretty rare but not impossible. The other tail is pointing away from the sun in the normal direction at about 301 degrees. They used different image processing techniques to look for fragments. They stretched the brightness. They made contour maps. They used false colors. They looked at the image in rings, moving outward from the center. Every technique they tried was designed to find even small pieces if they were there. They specifically wrote in their report that the imaged region showed no hint of fragmentation. If 3I Atlas had broken into 16 pieces like the math suggested it should, those pieces would be spreading out. They would be visible. They would leave trails. But the images showed none of that. So we are not just saying the object looks like it held together. We are saying astronomers carefully examined a massive region around it using multiple analysis methods and found zero evidence of any breakup whatsoever. And remember, this object just went through the most intense part of its journey. It passed closest to the Sun on October 29th. It got heated to extreme temperatures. We expected the thermal stress alone to have cracked it apart. The pressure from all that gas shooting out should have blown it into pieces. But 2 weeks later, it is still one solid object actively producing enormous jets in multiple directions. So if the object really is natural, which I think it is, scientists need to explain how this is physically possible. Here are the theories I have as of right now. We know 3I Atlas is probably billions of years older than our entire solar system, maybe 7 billion years old, maybe 10 billion years old. For all those billions of years, the comet was flying through deep space getting hit by cosmic rays. These are high-energy particles that slam into objects and change their chemistry. Think of it like radiation slowly cooking the surface over billions of years. The James Webb Space Telescope found something interesting that supports this idea. 3I Atlas has way more carbon dioxide compared to water than normal comets, about 8 times more than the usual ratio. This could be because cosmic rays converted carbon monoxide on the surface into carbon dioxide over billions of years. These cosmic rays could have also created a weird, crusty layer on the surface. This crust might make the ice underneath sublimate in really strange ways we have never seen before. Maybe it creates channels or pockets that give the comet way more effective surface area than we can see from the outside. Another theory is that maybe we are calculating the needed surface area incorrectly. Maybe sublimation can happen faster than we think under certain conditions. Maybe the jets are not carrying as much mass as the calculations suggest. The 50 billion tons per month number came from looking at how big and bright the tails are and calculating backwards to figure out how much material must be there. But maybe the tails are just really good at scattering sunlight. Maybe they look bigger than they actually are in terms of mass. If the real mass loss is only 5 billion tons per month instead of 50 billion, the numbers would work much better. That is still extreme, but at least possible for an object this size. The problem with this theory is scientists have been calculating comet mass loss this way for decades. The method works, so if it is suddenly wrong for 3I Atlas, we need to understand why. The third theory focuses on the internal structure of 3I Atlas. Maybe this comet is not a solid chunk of ice and rock. Maybe it is more like a rubble pile, loosely bound fragments held together by weak gravity. This structure could allow gas to escape through many pathways, creating more apparent surface area than the object's size would suggest. Or maybe there are large internal voids or cavities that allow sublimation to occur deep inside the comet, not just on the surface. If gas is being produced inside the comet and then finding its way out through cracks and fissures, the effective surface area could be much larger than what we measure from the outside. This would explain how a small object can produce such massive tails without breaking apart. The European Space Agency is showing us the object from a completely different angle in space that reveals some very unusual structures. These observations from a different vantage point are crucial because they help us understand the three-dimensional structure of the comet and its tails. When you observe an object from only one angle, you can be fooled by projection effects. Something that looks like it's pointing in one direction might actually be pointing in a completely different direction when viewed from another angle. But when multiple spacecraft and telescopes observe the same object from different positions in space, we can triangulate and figure out the true three-dimensional structure. The ESA observations confirm that the anti-tail really is pointing toward the Sun. It's not an optical illusion. It's not a projection effect. It's a real structure extending in the sunward direction. And that makes this object even more mysterious, because anti-tails are rare, and when they do occur, they're usually temporary features that disappear quickly. But 3I Atlas has maintained this structure for weeks, so why does all of this matter? Why should we care about one comet that's not going to hit us? Because 3I Atlas is only the third confirmed interstellar object in human history. We've been looking at the sky for thousands of years, and we've only caught 3 of these visitors from beyond our solar system. Each one is a window into another star system. a sample of material that formed around a different sun in a different environment under different conditions. If 3I Atlas truly is 7 to 10 billion years old, it's a fossil from deep galactic history. It preserves chemistry from an era long before the sun and planets even existed. The fact that it's behaving in ways we can't explain with our current models means we're learning something new. Either our models are incomplete, or this object has properties we've never encountered before. The unusual CO2-rich composition tells us that not all planetary systems are like ours. The chemistry that dominates in one star system might be completely different from what we see here, and the fact that it's staying intact while losing more mass than it weighs is forcing us to rethink how comets work. Maybe there are processes happening inside ancient interstellar comets that we've never seen in solar system comets. So here's where we are. 3I Atlas is doing something that should be impossible. It's losing 50 billion tons of material per month when it only weighs 33 billion tons total. The math said it should have broken into at least 16 pieces. But careful observations by two astronomers using multiple analysis techniques found zero evidence of fragmentation. It's still one solid object, still intact, still producing massive jets and tails in multiple directions. Scientists have three main theories. Maybe billions of years of cosmic ray bombardment created a weird, crusty surface that allows for extreme sublimation. Maybe we're calculating the mass loss incorrectly, and the tails are just really good at scattering light. Or maybe the internal structure is like a rubble pile, with cavities that give it way more effective surface area than we can see. The European Space Agency observations from a different angle confirm that what we're seeing is real. The anti-tail really is pointing toward the sun. The structures are three-dimensional, not optical illusions, and all of this is happening to an object that's probably twice as old as Earth, a visitor from another star system that's teaching us that the universe is far stranger than we imagined. In the coming weeks and months, more observations will be made, more data will be analyzed, and maybe we'll finally understand how 3I Atlas is doing the impossible. But for now, we're left with a mystery. An interstellar comet that's breaking all the rules and forcing us to question everything we thought we knew about how these objects work. If you watch to the end, drop me a like and subscribe for more updates. If you want to learn more about the other interstellar visitors that have passed through our solar system, check out this video where I break down the mystery of Oumuamua and whether it could be artificial. Thanks for watching, and I'll see you in the next one.